In this video, we are going to talk how to improve our linked list. That code that we already have is, well, let's say not really the best. And yeah, we are going to take the first improvements now. So the first thing is we want to fix the redundant part of our code. That means we have to repeat write we have to repeat to write every time malloc and yeah, that kind of stuff I showed you in the last video, that 3 lines or something, and we really need to write that every time we want to add a new element to our list. That's bad, of course. The second thing actually is not this one, but rather this one. We want to take out these kind of functions, like add a new element and put it inside of a C function. Like I mentioned initializing a list and adding a list, which will be covered in this video now. And this also will fix redundancy. That's the first thing. And the second thing is it will help us later to extend our list. Actually, we might have still some kind of redundant code in our source, but that will not be as bad as our code now. And the last thing is we want to separate our concept from the rest of our code for using it. That means we are going to write a header file and a source file for our list. That's actually leading us into programming style, which is of course something we also have to practice. So okay, let's not waste time and just go ahead. So yeah, this is the part of the list we are of course not we don't want to see that kind of thing anymore in our code, because first of all it will be redundant. This is just 2 elements for our list. If we have 10, our code will just explode, and that's of course a bad thing. The second thing is, this is our main function. This is our entry point for our software, and we want to keep it clean. We are really misusing it. That will not change in this video, but in a later video it will change a little. In object-oriented or fully object-oriented language, it will be a little bit better, of course. And another thing is, if another programmer will see this file, even he is good at C, he will not know what this file is doing. He has to analyze this by himself, and then of course he will know what this file is doing. But it would be better if we have some function calls here that have some names, function names, that will expose the meaning of what is going on here. This is also part of good coding style. So we will first start to add 2 new files to our program, a list header file and a list source file. Yeah, keep in mind that these .c extension files are called source files and the other files are called header files. The difference is not quite clear to many people. Many people actually, the C is not going to make a difference between header files and source code files, but the header files show what kind of or what functions are exposed by a source file. That means we will write the interfaces here and we will write the implementation here. Later in this video you will see what I mean. But the first things going to a header file are always type defs, variables, and that kind of stuff. So the first thing actually we're going to put inside of here is our type def for our list. Actually, it's also not really a list, it's just a list element, this struct, and all the elements in the list are called a list. So again, my naming skills are a little bit, yeah, not really good here, but it's okay. You know the concept. That is the important thing. Okay. Next thing is we have to include our list header. Don't forget, if you include your own files, you have to use the double quotes. And yeah, now our main file is using the list header file, and it's also important to expose or to include the header file and all other needed files to our source file for the list itself. Okay, earlier in this video I mentioned that we are going to write two functionalities for our list in this video. The first one was to initialize a list. We are going to call that function init, and the second one is to add new list elements. And the initialize function is actually just adding the first element that will initialize our list. And as we need the list in our main file, we should return that list element. And this is a pointer. That is what we are going to return, the head element. And in our main file, we will just call the init method or the init function, and that's it. That is what we are aiming for. Now, there's one thing we need to talk about, because we could, of course, initialize an empty list. In this video, I'm going to initialize a list with a value. The reason is that, first, in our example, we don't really want to initialize a list and then have an empty list, and maybe we are not going to use that. So we just have an empty list. We just allocated some memory for nothing. So we want to set a value to the list right on start, upon initialization. And the second thing is, maybe you want to use that list later on for some of your projects, or you need to do some homework or something. Maybe you don't want to use the integer value. Maybe you want to use a string value or whatever. So maybe you want to go here and set this one to a struct, because if you use a struct in all of this list, you can change the struct and just take whatever value you want, really. So as you can see, this value now is fixed. I could also go here and said, okay, I want a type def, and I just take the integer and just set it to element or something. So I could say this is of type element, and everything here is of type element. And later, if I want to change that value the list is taking, I just change the type def, and everywhere in my list it would be changed. If this is a little bit difficult to understand, don't worry, don't mind it. That is just really for people who want to take other values or who want it to change the value easily. Also later in this tutorial, we will also do that, and you will understand what's the meaning of this. Okay, whatever. We initialized our list with a value and returned the head. Our main function will just call the initialize function with a value, and then it's just like the 3 lines or 4 lines we had here before. I'm actually going to take this out. So we saved 3 lines in our main function, and we can reuse this initialize function in every other project that we want. That sounds great enough, but we also want to add new elements. And this is the code that we used before to add new elements. Here we actually don't have a return type, because we are providing a list. I call that R, list R, because of the root element. I am providing the root element of the list for this function, and of course another value that I want to add to this list. So now we have a little problem. If you want to solve that by yourself, you can pause the video. The problem is we want to add this to the end of our list, the value B, to the end of our list, which head is R. So how can we find the end of our list? Well, it's fairly simple. If you want to solve it by yourself, pause now because I will solve it now. First of all, we are going to use a loop for this task. And that loop is to check if the next list element is existing. So while the next element is existing, I will set the root element to the next element. Okay, so we have our first element, and this element has a descendant. So we just assign the next element as our root element, and then we try that again. Is the next element null or is it not null? If it's not null, it will set it to the next element until the next element is null, and then this while loop will be done. This while loop always assign the next value to R until the next value is not set. And when we reach that point, we can initialize a new node, a new list element with a certain value, and then we can say, okay, the next element now is node. And that's all, basically. So what we can do now is we can call the add function and provide our header element, our head element, and we can just put any number here, and then we can print that out. Well, actually we are still missing something, because you remember our header file, and I told you the implementation of our code will be in the source file, but we need to make that known to other files that we have an init function, and this is what the header file is for. We called that interfaces, I believe, in the video about functions. I already mentioned that you should always have some part in your code where you declare what a function looks like. And we did it like that. We omitted the names and just told the C that there is a function that takes 2 arguments, a list pointer, don't forget the star here, and here, that is of course the return value, and so on. And we are not really done yet, because these 2 functions, I believe before we made the interfaces inside the same file that also had the function, the implementation. But now this is the header file, this is the source file, that are different files, and that means we have to use the extern keyword here that will tell C, okay, I have some functions, please search them, look for them in some other file. That we have to provide these files. I will show you later how we do this. Okay, now we can print out our values. So the first value of our list is head value, and the second value of our list is actually head next value. Okay, now we can compile our project, and the compilation process also is a little bit different now, because we have to provide 2 files now. We have to provide our simple list.c, so our simple list, our main source file, and our list source file. And the output file is simple list. That will compile to 1 executable, and when we execute that, we get the result 3 and 25, just as expected. And now, to prove that this really is useful, we just add another value. The only thing we have to do is we have to call that by ourselves, third value of our list. Then we have to compile again, and we have to call it again, and we have 3 values. That's actually pretty great, because now we know we have a structure that can take whatever number of values, and we don't have to care about how many values. Maybe we will add some values that we didn't expect first at runtime. So that's actually pretty great, but we also we noticed that we struggle with some of the shortcomings of this data structure that we implemented now, because first of all, we didn't implement a function that can print every number of our list. And the second thing, of course, is what is if I want to remove a value from the list. So this is something we want to do in the next video. Like I said, we want to go on improving our data structure, our list. So first of all, we want to make sure we can print out the values, all the values of the list. And the second is we want to remove some values. This video was a little bit difficult, maybe because we introduced some new things like the external keyword for variables or functions that lay in another file. I introduced the compiling of the 2 files and into one file, and yeah, this separation of files may also be a little bit confusing first, but as you proceed and we go on practice, it will just be a routine for you, really. Okay, yeah, that's all for this video, and like I said, in the next video we are going to implement the next 2 functions and maybe find other problems with our list and improve it and go on, and then also meet other data structures. Okay, yeah, thank you so much for watching. See you in the next video. Bye.